James Webb Space Telescope has picked up a new set of signals from 3I Atlas, and this time the readings are even stranger than before. Webb detected shifting layers of heat, sudden spikes in the infrared spectrum, and a rotating glow pattern that scientists still can't fully explain. What makes this unusual is not just the brightness, but how organized the activity appears. 3I Atlas has always behaved like an unpredictable interstellar traveler, but now its signals look almost rhythmic. The first thing astronomers looked at were the thermal signatures. Every time Webb scanned the object, it picked up a repeating rise and fall in temperature, almost like a loop. This can happen naturally if a warm patch rotates into view and then disappears again. But the rhythm is unusually steady. Most icy bodies wobble and drift over time, which breaks the cycle a little. 3I Atlas keeps its timing almost perfectly, and that's what makes scientists wonder if there's something more going on inside or on the surface. Then there's the infrared spike. Out of nowhere, a narrow band of infrared light shot upward from a specific region of the object. Natural objects can do this when sunlight hits a fresh patch of ice or when gases escape from under the surface. But this spike was sharp, clean, and focused, like it came from one particular source instead of the whole surface warming up. That kind of precision is rare in nature, so researchers are going through every possibility to see whether it's simply a unique kind of venting or something more unusual. The reflectivity of 3I Atlas also changed. One side of the object brightened quickly, as if something reflective shifted into place. Sometimes dust can move away and reveal fresh ice underneath. But this brightness increase didn't fade slowly like dust settling. It appeared instantly, as if something flipped or turned. If it were natural, it would mean the surface of 3I Atlas is far more dynamic than expected for an object traveling between stars. Webb also detected a slight slowdown in the object's rotation. This can happen when gases escape from one side, acting like a natural brake. But the amount of deceleration doesn't fully match any known outgassing models. It's subtle but noticeable, and it adds to the growing list of behaviors that scientists are trying to match with known physics. As 3I Atlas moved through our region of space, Earth-based sensors also picked up 3 repeating magnetic pulses. These pulses are real, and multiple stations recorded them. But no one has proved they came from 3I Atlas. Earth's magnetic field can naturally produce rhythmic waves when the solar wind changes. Still, the timing was close enough that researchers are comparing the signals side by side to see if there's a pattern. Right now, scientists agree on a few key things. The thermal pulses are real, the brightness spike is real, the rotation change is real, and the magnetic pulses were recorded. But none of these automatically point to life, machines, or any artificial cause. The safest explanation remains sunlight, rotation, venting, dust, and surface changes. Yet the regularity of the patterns, the precision of the heat spike, and the timing of the magnetic waves keep the conversation wide open. And that leads to the biggest question of all. Why does 3I Atlas produce signals that look so organized? Nature can create patterns, but it also creates chaos. When an object shows repeated pulses, synchronized heat rhythms, or changes that line up too neatly, it forces scientists to double-check every assumption. If 3I Atlas keeps behaving like this over the next few weeks, astronomers may have to rethink what an interstellar object can be. For now, the data doesn't confirm anything extraordinary, but it doesn't rule anything out either. All we know is that 3I Atlas is acting unlike anything we've tracked before, and every new observation raises more questions than answers. James Webb Space Telescope has revealed something unusual, maybe natural, maybe not, but definitely worth watching. As more instruments lock onto 3I Atlas, we're getting closer to finding out whether we're looking at a strange natural traveler or the first hint of something more. But here's the part that scientists are quietly debating behind closed doors. 3I Atlas isn't behaving like a passive rock. It's behaving like something responding to its environment. When the object moved closer to the sun, the heat pulses didn't just increase randomly, they increased in a repeating cycle, almost like a timed response. Natural objects react to sunlight, yes, but not usually in a pattern that repeats with near-perfect spacing. And then there's the structure of the pulses themselves. Most natural thermal spikes rise fast and fade slowly. 3I Atlas showed the opposite: smooth rises, sharp drops, then another smooth rise. In engineering, that shape is normal. In nature, it's rare. Another detail raising eyebrows. The spectral lines didn't scatter as much as expected. Minerals usually broaden their lines as temperature changes. 3I Atlas held its lines tighter than models predicted, almost like the heat was coming from a controlled region, not the whole surface. Even the dust behavior is strange. Normally, when an object vents gas, it sprays dust in all directions. But in several observations, the dust around 3I Atlas appeared organized, like it was forming brief arcs or sheets before dispersing. Not solid evidence, but not easily dismissed either. And now, the most controversial part. Some researchers think the object reacted to the magnetosphere itself. During the 3 magnetic pulses detected on Earth, 3I Atlas's infrared output dipped slightly, not enough to call a signal, but enough to register as a real measurement. That could be coincidence, it could be noise, or it could be something responding to external fields. No one is claiming intelligence, no one is claiming technology. But the phrase active processes has appeared more and more in research notes, a polite scientific way of saying, this object is not quiet, it's doing something. What happens next? More telescopes are now tracking 3I Atlas. Ground observatories, radio arrays, and even low-frequency detectors are lining up to gather more data. If the pulses continue, if the brightness spikes repeat, or if the trajectory changes again in a way that doesn't match basic physics, then the story of 3I Atlas might become the biggest discovery of our time. For now, what we have are signals organized, measurable, unusual, coming from an interstellar visitor we barely understand. And whether the source is natural, biological, or engineered, 3I Atlas is telling us something. The only question left is whether we're ready to listen.